We're going to look at some problems on page 403, the lesson 6.6 assignment on systems of linear inequalities. So the first section, they're asking us to determine whether the ordered pair is a solution of the given system. So for number 7, they're asking whether 212 is a solution of that system. So for this, really all we're doing is seeing if this point works for both inequalities. So 212, we're going to substitute in the first inequality. So we'll put a 12 in place of the y. We'll put a 2 in place of the x. And then we're going to see if this works. So 2 times 2 is 4. 4 plus 4 is 8. So the question is 12 greater than 8. And it is, so that part works. Then we need to check it for our other inequality. So we put a 12 in for y. We put a 2 in for x. We've got 6 plus 7, which is 13. So is 12 less than 13? And it is. So that point worked for both inequalities. And so that would be a solution of that system of inequalities. Again, you don't have to go back and graph these and then see if 212 is in your shaded region. And if you'll notice when you guys do these problems, there's a little thing off to the side here that references a problem that you can go back to look at if you have questions on how to do that. So see problem 1 if you had issues with how to do something like this. So number 10 they want us to solve the system of inequalities by graphing. So what we're going to do is look at our solving for graphing to by graphing. The first inequality is solved these for were y. The ones, so we need to pick some points that would be on the line. We're thinking about the line y equals 2x plus 4. Even though it's less than, we're thinking about y equals 2x plus 4. Since it's a y equals something, we could put in 0, 1, and 2 for x and see what we get. So if you put a 0 in for x, that's going to be your y-intercept, so that'll be 4. If you put a 1 in for x, 2 times 1 is 2, plus 4 is 6. If you put a 2 in for x, 2 times 2 is 4, plus 4 is 8. So those would be 3 points that would be on that line. Before I go to graph that, I'm going to go ahead and find some points on my other graph so that I have an idea of how big my graph needs to be. I need to look for what my smallest and biggest x and y values are so I know how big the graph needs to be that's going to fit all the points on it. The second equation, the x and y are on the same side. If they're on the same side, it's usually going to be easier for you to do the intercepts. So if we put a 0 in for x, negative 3 times 0 is just going to be 0. So we've got basically negative 2 equals 6. So y would be negative 3. So 0, negative 3 would be 1 point on that line. Then we could put a 0 in for y. Negative 2 times 0 is 0. So we've got negative 3 equals 6. And divide by negative 3, and that would be negative 2. So negative 2, 0 would be another point on that line. So these would be some points that would be along these boundary lines for our inequality. If you'll notice, the smallest x value we have is negative 2, highest x value we have is 2, lowest y value is negative 3, and the highest y value is 8. So I'm going to go ahead and graph this on the graph here, which goes from -10 to 10 on the x and y. So if we graph our first points, we had 0, 4, 1, 6, and 2, 8. And when you graph those should line up with each other. This inequality, it was y is less than 2x plus 4. This line would be y equals 2x plus 4. So since it's just less than, then we would need to have a dotted line or dashed line. And then we can think about which side of our line we would need to shade on. Like I've mentioned before, since it's y is less than, if the y is by itself and you have less than, you're going to be shading below the line, if that makes sense to you. So this would be shading below the line. The safe thing would be to try that point 0, 0, like we've talked about. So if we try 0, 0, I don't have a whole lot of space doing all this on one page here, but if you try 0, 0 with that first inequality, basically we'll end up with 0 is less than 4. 0 is less than 4, that's true. So we would shade on the side that 0, 0 is, which is where we said we were going to shade. So if we look at our second inequality, I'm just going to use a different color to distinguish it. So we've got 0, -3 was one of our points, and -2, 0 was another point. This one, it was greater than or equal to, so that's going to be a solid line. And then we need to think about which side to shade it on. So picking a side to shade it on, we just need to pick a point that's definitely on one side or the other. If the line does not go through 0, 0, that's a nice point to pick, because zeros are easier to work with. So I'm going to do 0, 0 because it's definitely not on our line. If we try 0, 0, basically we come up with 0 is greater than or equal to 6. That's not true. So 0, 0 0, 0 would be here, which is kind of above that line we might think of. So 0, 0 didn't work, means none of the points up here work. Means all the points on the other side of the line would work. So we would need to, for that line, shade down here. And then ultimately what we're doing for a system of inequalities, it's got to be for our final answer where the two shaded parts intersect each other. So where they both are at is in this little triangle at the bottom. So the final answer would be just this region here. Technically, these other parts, you know, to make it clear, if you wanted to go back, it's not letting me erase this part with those black slash lines there, but you know, just that blue region, anything in there would be possible answers for this problem. Number 16, we've got x and y both on the same side of the equation, so we could use intercepts for that. So if you put a 0 in for x, basically we got 2y equals 10, so y would be 5. Put a 0 in for y, basically you'd have left would be x equals 10. And then for this other graph, we could do 0 and that'd be 4.5 or 4.5. You put a 0 for y, and that would be 9. And then you could graph that. So that this one I'm graphing first here, that'd be a solid line. If you try 0, 0, you'll get 0 is greater than or equal to 9, which is not true, so we'd be shading above that line. For the other line, line would be something like that. If we try 0, 0 there, would be 0 is less than or equal to 10, which is true. So we'd shade below that line because 0, 0 is below the blue line. So it'd be just this little piece in between here would be there where those lines are. And those would both be solid lines since it's or equal to on both of the graphs. For number 22, they want us to write a system of inequalities for the graph. So basically we have two different lines here. We got the blue line and the red line. So the blue line, if we look at that, we could look at where our y-intercept is. Okay, so for the blue line, y equals mx plus b is kind of our general slope-intercept form that we've used a lot. So our y-intercept is 2. If we look at this line, another point I see on this line is 1, 0. To get from 0, 2 to 1, 0, that'd be going down 2 and over 1. So slope is changing y over changing x. So our slope is negative 2 over 1. Negative 2 over 1, which is the same as negative 2. So our slope is negative 2. So that blue line, the equation of that would be y equals negative 2x plus 2. It is a solid line. So it's just a question, is it greater than or equal to or less than or equal to? So we could try this one. We have the y by itself. And if you look, the blue, where they shaded blue, looks like that would be above the line. So it's going to be greater than or equal to, would be that line. And again, you could try 0, 0 to make sure that works. If you do that, 0, 0, we would be saying 0 is greater than or equal to 2. 0 is not greater than or equal to 2. And that 0, 0 is, in this case, below that blue line. 0, 0 did not work, means we need to shade above that blue line, which is what they did. So that inequality is correct. Then if we look at the red line is a dotted line. So we'll have to make sure we consider that. Just worry about the line first, though. Okay, if we're right on the line, y-intercept is negative 2. The slope looks like we're hitting at 1, 1 up here. So 0, negative 2 up to 1, 1. So that would be going up 1, 2, 3, and over 1. So up 3 and over 1. So our slope is 3 over 1, which is the same as 3. So that line, our equation would be y equals 3x minus 2. We have a dotted line, so it's not including the line. So our actual answer is either going to be just greater than or less than. This is a y equals equation, how we've got it set up. And if you look, it's pretty steep line, but if you can imagine, it's kind of shading below the line. So this should be y is less than 3x minus 2. If you try 0, 0, you'll get 0 is less than negative 2. 0 is not less than negative 2. So 0, 0 does not work. So here's 0, 0. Here's our red line. So this side does not work, means this side works. And you can see that's what they did. They shaded this direction where they got that yellow piece, and then the green is where the yellow and blue are overlapping each other. So those would be the two inequalities that would make that graph. For 24, we have two lines here. Both are dotted lines. If we look at the blue line, the blue line y-intercept is at 3, and the slope looks like that's a point, so that'd be going down 3 and over 2. So the slope would be negative 3/2. We're shading below that line, so that would be y is less than negative 3/2 x plus 3. And then our other line is a vertical line. A vertical line actually is a x. X's are always the same. So that's like x equals 2. If you'll notice, we're shading to the left of that, so our x values would be less than 2 for that part. For 26, you have a job mowing lawns, $12 an hour, working at a clothing store, $10 an hour, and you need to earn at least $350 a week. But you can work no more than 35 hours per week. And one more thing is you must work a minimum of 10 hours per week in the clothing store. So some inequalities with this, we'd have 12x plus 10y is greater than or equal to 350. That would be based off of our pay. X plus y is less than or equal to 35, because we can work no more than 35 hours a week. And you have to work at least 10 hours a week in the clothing store. So say y is greater than or equal to 10. We should define our variables here. X would be the hours in the hours mowing, and y would be the hours working at the store, at the clothing store. Okay, we'll define them a little bit nicer than that, but you get the idea. And then if we were going to graph this, some points, we would have 0, 35. If we did another intercept, would be 29 and 1/6, 0. And then for these, we could do intercepts 0, 35, and 35, 0. For this one, think about y equals 10. So you could make up some points there. Y is always going to be 10 though. So this is an idea of what the graph would look like for that. So we've got to be below the red line and above the green line and above the blue line. So there's just this little sliver in here that would work. So not a whole lot of options with all those limitations that we have. (27) Without reading this all out, we're going to have an equation for the distance driven. So 60x plus 55y is greater than or equal to 500. The time driving part is at one speed, part's at the other speed. X plus y is less than or equal to 10 because no more than 10 hours of driving. And there's actually a stipulation here. The friend who drives slower wants to drive fewer hours. So the one that's driving slower is the y. So y needs to be less than x. So if you graph those all out, it should look something like this. We need to stay above the red line, below the blue line, and to the right of the green line. So we're kind of looking at this little section over here. (28) We're fencing a rectangular area, and we only have 150 feet of fence, and we want the length to be at least 40 feet, and we want the width to be at least 5 feet. So they want us to graph this. So defining our variables, we could let x represent the length of the garden in feet, and let y represent the width of the garden in feet. So the length we want to be at least 40. So x is greater than or equal to 40. The width at least 5 feet. So y is greater than or equal to 5. And then we only have 150 feet of fence. So if you think about what's happening, this is kind of what our garden looks like. So our perimeter, we have 2 x's plus 2 y's. That's going to have to be less than or equal to 150. So those would be some different things that we'd be working with. If we were graphing this, then we can do intercepts on this would be 0, 75, and 75, 0. Obviously, we can't have just lengths and no widths, because then this wouldn't be closed in. Okay, maybe we're trying to keep deer or animals from eating our garden, so we've got to close it in. So when we graph, this is something like what our graph should look like. And so it's in this triangle here would be the different possibilities that we could do. And technically, if you want the most area enclosed and using the least amount of fencing, the closest to a square that you get is going to be maximizing your area for using that amount of fencing. So, you know, if we do 150 divided by 4, each length and width equal, that would be the most efficient use, as long as that works out. Obviously, in this case, we're saying x has to be at least 40, so that doesn't work with the constraints of what they're asking us to do, but generally that would be maybe a consideration to do. Number 31, you received a $100 gift certificate. The store sells t-shirts for $15, dress shirts for $22. And you want to spend no more than the amount of the gift certificate. You want to leave at most $10 unspent, and you need at least one dress shirt, and so we want to find our combinations. So for our costs, we could say 15x plus 22y. We're going to make x be our t-shirts and y be our dress shirts. Okay, we should define those a little bit nicer, but you get the idea. So if we don't want to spend any more than the amount of the gift certificate, means 15x plus 22y should be less than or equal to 100, would be one of our inequalities. And you want to leave at most $10 left unspent. At most $10 left unspent means we're going to be spending at least $90. So also 15x plus 22y is greater than or equal to 90. Another inequality is we need at least one dress shirt. So dress shirt y is our dress shirt. Y is greater than or equal to 1. So if we do this, we could do intercepts if we wanted to graph. Not real great numbers here. This would be 0 and 4 and 6/11. This would be 6 and 2/3 and 0. One nice thing about the intercepts, though, is it gives you an idea of kind of what your maximum amounts might be that could work. 0, 4 and 1/11, and 6, 0. And obviously, we're not going to buy part of a t-shirt or a dress shirt, so we want to make sure we have whole number answers here. So if we graph these inequalities, this is kind of what we're looking at. T-shirts is the x-axis, dress shirts is the y-axis, and it's kind of just that little trapezoid, I guess we could say, in between here would be what our solution is, our final solution. And then we could look for different options. What are all the possible combinations that you could buy? So 5 t-shirts and 1 dress shirt, you can see that the 0.51 is inside of that region. 2 t-shirts and 3 dress shirts, that also is in the region. It almost looks like we could do 3-2. 3-2 is really close, but actually if you work it out, 3-2 is $89. So we're not spending the $90 at least by doing that. And then also we can't do the 6-0 because we need at least 1 dress shirt. So that's actually, I messed up here. This part down here actually is not part of our shaded region. It's just the part in here. Okay, it's got to be above this line here. So that's the reasoning for that. So there's actually only 2 different combinations that meet the criteria here. For 33, if we think about this, we know we have the 2 solid lines. The question is, which part are we going to shade? So if we try 0, 0 with these to see if it works. 0, 0, that'd be 0 is less than -2. That's not true. This would be the red line, because you can see our y-intercept is -2 and slope is negative. So 0, 0 didn't work. That's above the line, means we need to shade below the line. So we're either looking at the third or fourth section here, section 3 or section 4. And then if you try the other equation, 0, 0, is 0 greater than or equal to 6? And the answer is no. So 0, 0 did not work in that one either. 0, 0 is to the right of the blue line, so we need to go to the left of the blue line. So if we look at where those overlap, that would be section 3. So that would be choice C would be your answer for that problem. Number 36, we have a jeweler that's going to produce a ring made of silver and gold. Price of gold is $25 a gram. Price of silver is 40 cents per gram. Big difference. She considers the following in deciding how much gold and silver. All right, so gold, $25 a gram. Silver, 40 cents a gram. Total mass must be more than 10 grams, but less than 20 grams. It must contain at least 2 grams of gold, and the total cost must be less than $90. So we have several inequalities here. One inequality is going to involve the cost. So, if we just let X represent grams of gold and Y is the grams of silver. I'm not going to write it all out just for time's sake here. Okay, so if we look at our cost inequality, we should have 25x plus 40 cents times Y would be our cost, and it has to be less than $90, so less than 90. That would be one inequality here. We also have inequality about mass. So the total mass has to be more than 10 grams. So total mass would be adding those together. So X plus Y has to be greater than 10 would be another inequality. Has to be less than 20 grams total. So X plus Y is less than 20. That's another inequality. Has to have at least 2 grams of gold. So X is greater than or equal to 2 would be another inequality. And we already talked about the costs. So these would be our 4 inequalities that we would need to be working with. And they want us to graph these and then find one answer that works. So if we take this inequality, X and Y are on the same side, so intercepts would be the easiest route. If you put a 0 in for X, divide by 40 cents on both sides, you'll get 225. So one option with our cost would be no gold and 225 grams of silver. Obviously that doesn't fit all of our other criteria. You could put a 0 in for Y and then divide by 25, and that would be 3.6 or 3 3/5. So we could get just a few grams of gold and no silver would be another option. Another inequality, x plus y is greater than 10. Think about x plus y equals 10, and we could do intercepts here. Put a 0 for x, y would be 10. Put a 0 for y, x would be 10. Less than 20, same idea. 0 for x, y is 20. 0 for y, x is 20. Okay, and then that other one that is like x equals 2, that's just going to be a vertical line. Think of x equals 2. X is always going to be 2, and y is going to be whatever. Okay, if that helps you to see that that's going to be a vertical line. So if we look at our points that we've found, we have a y value of 225. That's pretty big. Our highest x value is 10. So we could probably be okay actually just going by ones on our x-axis. Maybe we'll go by 25s on our y-axis. So silver grams and gold grams. So for the y, if I go by 25s, I need to mark that off. And, you know, I could have gone by 10s or something, wouldn't be quite so scrunched up, I guess. But anyway, so 0 to 25 is one of the points, and we had a 3.60. If I don't mark anything on the x-axis, we're going to assume we're going by ones. So this would be my cost, and this needs to be less than 90. So this is equals, so we would want a dotted line. Less than would be below that line. So far we're already restricted to that little triangle. Our other one, we had greater than 10, x plus y is greater than 10. So we had 10, 0 and 0, 10. And again, maybe going by 10s would have been a better choice here because I'm really not allowing myself to see this very well at this point. And that would have to be above that line. So if you want to, you already know you're restricted to that one little triangle. You don't have to shade everything above. If you want to just keep restricting what works, you can do that. Our other one, we had 20. So we've got 20, 0, and 0, 20. And we want to be greater than that, so we'd be above that line. So that's restricted us a little bit more again. Oh, sorry. That was less than. So we'd actually want to be below that line. So we're kind of in between those two lines and inside that triangle. And then we have our last one is x is greater than or equal to 2. So x equals 2 would be a vertical line. Greater than or equal to would be to the right of that. So we basically end up with this little section here. And like I said, this graph that I did is not the best way to do that probably, but you can see, I mean, it looks like we've got a for sure point maybe here if nothing else. So that'd be at what, 225. So that'd be 2 grams of gold and 25 grams of silver would be one option that would work to fit all those criteria. Okay, and understand this is kind of on the upper end, just showing kind of what you guys can do with this stuff. This would be, you know, we're not going to get anything more difficult than a problem like this. So a couple other takes on this graph, I guess, would be something like this, and there's just a little black section here that I've shaded in. That would be our solution. On the book's answer for this one, what they show to me anyway, the one line looks like it's vertical, but it's really not. So that would be one take of that. Here's kind of a big picture of what that would look like. And then kind of if we zoom in, if we zoom into it, then you can see a little bit better. The section would be just right in here. Okay, so again, just a little tricky with the windows to get it to where you guys can see that real well on that problem. So sometimes you might just have to adjust your intervals and things so you can see it better. Number 38 here is question. And what we have to watch on this problem is that we have the one part here, it says 20 feet, but then everything else is in inches. So 20 times 12, that'd be 240 inches. So with that information and the other information you were given, some different inequalities, you could have one inequality would be 11.5x plus 14y is less than or equal to 240. And the reasoning for those numbers is we're leaving 3 inches of space to the left of each art piece. So the 11.5, actually we get that by doing 8.5 inches plus 3 inches. And the 14 is the 11 inches plus 3 inches. Okay, it's just that we're doing a 3 inches extra on the left side. So that's one of our inequalities. The other thing is she's going to post at least 16 pieces of art, so x plus y is greater than or equal to 16. So for graphing, if you use intercepts for this one, that's 0, 16, and 16, 0. For this other one, we can also use intercepts. The answers don't come out quite as nice for that one. That'd be 0 and 17 and 1/7. and then 20 and 20/23, 0. Your other option would be solving it for y and then substituting numbers into that. So the graph for that would look like this. And we'd want to stay in the first quadrant, so you can kind of ignore everything outside of that first quadrant. And you can see this little sliver in between here would be possible answers for this problem. Obviously for this, we're talking about how many works of art, how many pieces of art that she's posting. So you'd want to make sure that you had whole number answers. You know, we're not going to post 5.5 pieces of artwork, for example. So hopefully this helps with the lesson 6.6 assignment.